In this video, we're going to have a look at integration by parts. I'm going to explain where the formula comes from and just look at some basic examples. Now, we know that every differentiation rule has a corresponding integration rule that goes either way. So we've looked at integration by inspection or using a substitution. That corresponds directly to the chain rule. Then now we're going to look at the rule that corresponds to the product rule for differentiation. And this is called integration by parts. Let's first look at the product rule and then work backwards. Now the product rule states that if I've got two differentiable functions, f and g, then if I differentiate their product, it'll be the first function times by the derivative of the second, plus the second function times by the derivative of the first. Now remember, integration goes either way. So what we're going to look at is the notation for indefinite integrals, where the integral of this story, and there it is, will then be equal to f of x times g of x. I've just gone the other way around. Now what I can do is split that integral over the sum. So it's the integral of the first term plus the integral of the second term. That's what I have here, is f of x times g of x. And now what we're going to do is we're going to rearrange it so that we have this as the subject of the formula, in which case I need to subtract that. So I want to get that as the subject of the formula. And I land up with the integral of f of x times the derivative of g of x is equal to the product of f and g minus the integral of g of x times the derivative of f of x. And this is integration by parts. So here I've put the formula again. That's what we are going to be using whenever we do integration by parts. Just take note at all the different elements of that formula again. I'm going to have a function f times by derivative g. If I integrate that, I'm going to have function f times function g minus the integral of g times the derivative of f. Now, integration by parts is used mainly in the case of a product of two completely unrelated functions. So we've had products before, but we've been able to see a composite function and the derivative of the inner function. That's what we did with integration by inspection or by using substitution. But here we have two completely unrelated functions. And these other methods aren't working for us. We can try integration by parts. I'm going to briefly go through the method, but then I'll revisit it as we do an example, because then it makes a bit more sense. So first we choose one function to be f and the other function to be our derivative. So if we have a look at our formula, we can see that we've got a product of a function and a derivative. So we choose one to be the function, one to be the derivative. Now, when we make that decision, here are some suggestions that will help you. So try allowing the derivative of g to equal the most complicated portion of the integrand. That's the function you're integrating. And it must fit to a basic integration rule. So that's one way to choose your derivative. Another way is try allowing f to equal the portion of the integrand whose derivative is simpler than it. So often we go for an algebraic expression there. Now, the acronym LIATE can help you make your choice. Now, at advanced program level in high school, we actually only really look at the A and the T, but I'm showing you the whole acronym because if you're taking maths at varsity, it's going to be a very useful acronym. It means that we look for logarithmic functions first, then inverse trig functions, which we don't do in AP. Then we choose the algebraic part, then we look at the trigonometric part, then the exponential part. But at the moment, you're just picking algebraic and trigonometric. Often these functions will have both. So the algebraic will be your f, and that leaves the trigonometric part as your derivative of g. So now we finish up, because if you have a look at your formula, let's just go back here. We also need the derivative of f, and we need the actual function g. So what we do is we calculate those from our f and our derivative of g. If we've got, remember we will have the derivative of g, so we just get its antiderivative in order to get the actual function g. Substitute all of those things into your formula, integrate where necessary, simplify, and don't forget to add your constant of integration if you're doing indefinite integrals. Alright, so let's look at an example. And I'm going to use lots of color here to just help to understand exactly what's going on and for different parts to stand out. Alright, so you might look at this function and think, could I do it by inspection? But hang on a second, I've got a bit of a problem. I've got really unrelated functions here. Couldn't use inspection, I couldn't use substitution, so I'm going to try integration by parts. So our first step in integration by parts is, and let me actually just revisit that. The first step is we need to find that f and that derivative of g. So choose one of my functions to be f and the other one to be the derivative. Okay, so let me choose a purple here. I'm going to choose, and remember Liate, you actually just worried about the a and the t. Choose your function to be an algebraic one and your derivative to be a trig. So my algebraic function in this product is x. So I'm going to make my function f of x to be x, which means that my derivative of g will be the other function, sine x. Right, so based on that, let's actually differentiate. So the derivative of x is 1, and so now we need to actually integrate sine x to get our original function. So I'll just do that up here just so that you can see what we need to do. I want to integrate sine x with respect to x. Now if you go back and have a look at your table, you look at your derivative column and you only see a negative sine x. So let's put a negative and a negative. The integral of negative sine x is cos x. And then obviously it would be plus a constant. So what that does is you only need that part there. And you plug that in over here. And just check if I've got the function negative cos x. If I differentiate it, I'm going to get sine x. Cool. So I've got the 4 different parts that need to go into my formula. I'm actually just going to rewrite my formula just for this example. Remember, it's on your formula sheet, on your information sheet. You can go and check it out. Let's use colors again. The formula says the integral of a function f multiplied by another function which we've called our derivative function with respect to x is equal to the function f of x times by g of x minus the integral of g of x times by the derivative of f with respect to x dx. Okay, so the color should help you see how all of these guys are going to fit in there. So let me just translate it into the example we're doing. The example that we're currently doing is asking me for the integral of x times by sine x with respect to x. See, I've just translated these guys down. There's my function. There's my derivative function. Now I need to follow the formula. So actually integration by parts now just involves subbing into a formula. So instead of f of x, I'm going to put x instead of g of x, I'm going to put negative cos x. I'm just going to put it in brackets because I'm multiplying. So I've translated, there's my function. There's my function g of x minus the integral of g of x, which is negative cos x, times by the derivative of f, which is just 1 with respect to x. So see how I've just subbed that in. Alright, so now at this point I can integrate, I can simplify. So let's carry on. Here I've got x times negative cos x, which is negative x cos x. Then a minus and a minus, here minus and a minus gives me a plus the integral of cos x times 1, which is cos x with respect to x. So that's negative x cos x plus the integral of cos x. Go to your table that shows you functions and derivatives. Go to the derivative column. Now go back and see what goes with cos x. We know that the integral of cos x is sine x, and don't forget to add your constant of integration. So that's how we use integration by parts, where we pop everything we need into our formula. In the examples to come, in this video and the next one, I'm not going to write out the formula every time, and I'm going to keep referring back to it, just like you would refer to it in your information sheet. Let's have a look at another example. Okay. Here we're looking at the integral of x cos 3x. Again, you try everything else that you've learned so far. Could you use inspection? Do I see the derivative of my inner function here? Got a bit of a problem, I don't. Okay, and it's difficult with the trig function to use substitution. Often if this was all algebraic, then you could use a substitution instead. But now we've got two seemingly unrelated functions. We've got x and we've got cos 3x. So just have a look back at your other example. The first thing we're going to do is we're going to look at f, we're going to look at the derivative, we're going to look at then calculate the derivative of f, and we're going to calculate the integral of that to get your g. So let's do that here. Remember, use liate to help you, just the a and the t. The a means you choose your algebraic function as your f. So I've got my f of x is equal to x, and then that means the other function will automatically be my derivative function, and that's cos 3x. Now let's differentiate. The derivative of f, in this case the derivative of x is 1. Now we want to integrate, and we want to find g of x. So remember, this should later be happening in your head, but I'm going to write it down. What you're doing is you're integrating cos 3x in order to get the original function. Remember, when you integrate cos of a linear function, you've got 1 over 3. The integral of cos 3x is sine 3x. And then plus your constant. But this is all you need to pop in there. So here I've got a third sine 3x. Alright, so let's look back at our formula. I'm actually going to just write it out. Remember, you can just go and get it out your formula sheet. So I'll just write it out here just so that we've got it in front of us again. So your formula, we know that integration by parts is the integral of a function times by a derivative is equal to the product of the functions minus the integral of g times by the derivative of f. Okay, so let's just keep that in the back of our minds. Let me just draw a block around it. So we're just keeping that formula in the back of our minds, straight from your information sheet. Cool. So what we've got here is we've got this. This is x times cos 3x dx. We want to sub what we have here into this part of the formula. Right, so which means we've got f of x times g of x. I always like to think I'm going diagonally. I've got f of x times g of x. So let me use my colors. F of x is x, and I'm timesing it by g of x, which is a third sine 3x. I've now covered that part. So I'm going to go minus the integral of g of x, which is third sine 3x, multiplied by the derivative of f of x, which is just 1, and that's with respect to x. Now what we need to do is actually just work on each individual integral and simplify where we can. So this I can simplify to x over 3, because that's x times the third, sine 3x. Now let's have a look at the integral. I can take that third out. Okay, so I'm going to take the third out, and I'm looking at the integral of sine 3x times 1, which is sine 3x. Now remember, when we go to your columns, your function and derivative, we don't have a sign of an angle in our derivative column, but we got a negative. So I want to make that a negative, and I take a negative out, making that a positive. Cool, so let me go one step further. I can't integrate this anymore, I can't simplify it anymore. So I just leave it. Then I've got plus, my third is sitting there. The integral of negative sine of an angle is cos of the angle. But remember, to counter for the 3 in the chain rule, you've got to times by a third. We've done integrating, so I've got to add my constant of integration. And now I just pretty it up in the last step, simplify where I can. So it's plus 1 over 9 cos 3x plus the constant of integration.